This is section 7.2. It's on the converse of the Pythagorean theorem. We talked about that in our last video. What we're going to do is a couple examples in this one. We're going to verify whether or not these triangles are right triangles. So this isn't multiple choice. We have three lengths. We have to decide if that makes a right triangle. So remember what the converse of the Pythagorean theorem says. Take your two smallest sides, which would act as your legs if it is a right triangle, square them and add them. Take your biggest side, which would act as your hypotenuse if it is a right triangle, and square it. Does this equal this? Okay, well, I'm just going to type it into my calculator. I know you can't see it, but I'm doing 14 squared plus 22 squared. Oopsies, I messed up. 14 squared plus 22 squared. That gives me 680. 26 squared, that's not even on your perfect square list, but it's 676. These are not equal. So is it a right triangle? No, it's not a right triangle. Now, if it's not a right triangle, it's got to be some type of triangle. We'll talk about that more in a second. Let's try this one. 9, 15, and another length. Notice how this length has a radical in it. And I know that automatically looks confusing. Is this side bigger than these sides? You need to know that because you need to know which side is the longest. Obviously 15 is bigger than 9. Is 15 bigger than this? Okay, well, let's think about it. Square root of 34. Do you agree that that's almost 6? The square root of 36 would be 6. Square root of 34 is a little bit smaller, but this is almost 6. 3 times 6 is 18, so 3 times something a little bit less than 6 is going to be a little bit less than 18, but it's probably still going to be bigger than 15. You can type it into your calculator. What is 3 times the square root of 34? It gives me 17.49. Okay, so this is the biggest side. That's important. That way you can set up your converse. You have the potential legs identified correctly. Now, the other issue with this is typing this into the calculator. A lot of people make errors when you do that. This is simple. I'll just type that in now. 9 squared plus 15 squared. That gives me 306. Now, depending on how you type this in, you're probably going to get a couple different things because you're doing it correctly one way and incorrectly the other ways. Use parentheses. So put a left parenthesis, then do 3 square root 34, end parenthesis. Make sure you end your radical too, depending on if you have a new calculator or not. End that parenthesis, then square it. It's also going to give you 306. Now, if you didn't like doing it this way, you could have done this. 3 square root of 34 times 3 square root of 34. You need to multiply 3 times 3, which gives you 9. Then multiply 34, square root of 34 times square root of 34, which just gives you 34. It takes the radical off. 9 times 34 is 306. So you could have done it that way too if the calculator way is too tricky for you. But these equal each other. So this is a right triangle. Tell whether a triangle with the given side lengths is a right triangle. So it's the same thing, except they don't have the side lengths. Now, notice how this guy, that's supposed to be that. I don't know why that's floating there. This guy that's floating there should be here. Not sure why that happens. Well, these lengths make a right triangle. It's important to know if they're in order. 4 square roots of 3. Square root of 3 is less than the square root of 4, and the square root of 4 is 2. 4 times 2 is 8. So 4 times the square root of 3 is going to be a little bit less than 8. This is your biggest side. If you're not sure, type it in the calculator. 4 squared plus 4 square roots of 3, that whole thing squared. Does that equal 8 squared? Well, I know 8 squared is 64. I know 4 squared is 16. But what about this guy? What is 4 square roots of 3? Also, if you have trouble typing all of that in as one expression, you can type it in as just individual pieces. You could type in 4 square roots of 3, hit enter, and then square it from there. That might be easier. Okay, so what happens when you square this, if I did it separately, I typed in 4 square roots of 3 and I got 6.928, then I squared it right after that and I got 48. 4 squared 16. What is 16 plus 48? That gives you that same 64. Is this a right triangle? Definitely. What about 10, 11, 14? This one's simple because I don't have to decide which one's the biggest number. I know 14 is the biggest. Ten squared plus 11 squared gives me 221. 14 squared is 196. These are not equal. It is not a right triangle. Now, that does mean that it is some type of triangle. If it's not a right triangle, what kind of triangle could it be? Okay, let's do one more. 5, 6, and the square root of 61. Square root of 61, that's bigger than the square root of 49. Square root of 49 is 7, right? So the square root of 61 is definitely bigger than 7, if that makes sense. That's your biggest side. You need to know that way you set this up correctly. If you don't put your biggest side on the right by itself, then you're going to get this wrong. Okay, now evaluating this looks difficult. Square root of 61 squared. The squared is multiplying this with itself. So if you are unsquaring something and then squaring it again, you're basically just canceling those two operations out. Square root of 61 times itself gives you 61. What is 5 squared plus 6 squared? It also gives you 61. This is a right triangle if you have these lengths. This is a right triangle if you have these lengths. These lengths don't make a right triangle.